Hello everyone, greetings of the day. Welcome to the Be Smart family. I'm Sana Nadaf. Let me take this opportunity to brief you about the company. Be Smart is founded by the alumni of NITs, IITs and the corporate professionals. Be Smart is a digital learning platform which focuses on enhancing the knowledge base of the students by focusing on the basics, concepts and the practical applications in real time. Be Smart believes in futuristic utopia of learning. We are amongst the earliest in the country to integrate adaptive learning into engineering courses. Herein, we make use of advanced technologies and tools to provide personalized learning experience to the students in a very lucid manner. Be Smart intends to handhold the student throughout the entire course and make them industry ready. So, without further ado, let's move on to the subject. Thank you.
I'm Sandeep. I'll be delivering sessions on Engineering Mathematics 1. I've completed my BSc, MSc in Mathematics from Osmania University and MPhil in Mathematics from Periyar University. I've been in this teaching profession since 12 years. I've started my career in teaching in the year 2005. Apart from engineering subjects, I also conduct sessions for IES, GATE, CSIR, etc. When it comes to Engineering Mathematics 1, it forms the basics for higher semester subjects like M2, M3, M4 and various other core subjects. Now without any further delay, let's proceed to the subject module by module. Now, in this session we are going to learn about the module 1. So in module 1 we are going to learn about the successive differentiation. So in successive differentiation we are going to find the nth order derivatives of some standard functions and the Leibniz theorem for nth derivative. That means when a function is given, how to find out the nth derivative of a function by using the Leibniz theorem. And again we are going to learn in the second topic as the polar curves. So in polar curves, what are the polar coordinates? We are going to learn about the polar coordinates and we are going to learn about the angle between the radius vector and the tangent. And again, so the length of the perpendicular from pole to the tangent to the curve and the angle between any two polar curves which are intersecting and the Pedal's equation for the polar curves. And we are going to learn about how to find out the arc length and as well as what is the curvature and what is the radius of curvature. So these are the topics that we are going to learn in the module 1. And all these topics, like if we are taking the nth order or successive differentiation, so these topics are again all these topics, so whatever the problems that we are going to solve, so all these topics are again used in the next modules. So we have to concentrate more on how to find out the derivative for a function as the higher order, and so this is the main topic which is useful for the next coming modules. So now first we'll start with the successive differentiation and what is the derivative and how to find out the successive differentiation for a given function, and we'll write some nth derivatives for the standard functions like e to the power ax, so and again x to the power n and sine ax and so on. So we are going to find some standard functions, or we are going to derive some standard derivatives or the derivatives for some standard functions, and we'll use the Leibniz theorem in order to get the relation between them. Now we are going to learn about the successive differentiation of a function. Now let us say we are having a function y is equals to f of x of one independent variable, that is x. And we all know how to write the derivative. So the derivative is written as the first order derivative. So that is dy by dx, or that will be written as f dash of x, or that can be written as y dash of x, or that can be written as y1 of x, or again we can write this as dy. So we can denote a first order derivative as f dash of x or y dash of x or y1 of x or dy, where this d represents d by dx. And if I go on differentiate this derivative again and again, so if we are differentiating again, so then what do we get? That is d by dx of dy by dx. So then that is equals to d square y by dx square. And again, if we go on differentiating this, so differentiate it again and again, so what do we get? So we'll be getting it as like d cube y by dx cube, or d by dx of d square y by dx square, and that will be d cube y by dx cube. And if I differentiate it again, so that is d by dx of d cube y by dx cube, so then that can be written as d to the power 4 y by dx to the power 4, and so on. So if we go on differentiate till nth time, so that means the nth derivative will be d by dx of d to the power n minus 1 y by dx to the power n minus 1, that can be written as d to the power ny by dx to the power n. So then we'll be calling this one as the second order derivative, and this one as the third order derivative, and this one as the fourth order derivative, and this one as the nth order derivative, or simply nth derivative. So we'll be denoting the second order derivative as y2 or d2 or d square or d2. So according to our convenience we can denote them. Now in the same way, the third order derivative is y3 or d3 or d to the power 3. And in the same way, the fourth order derivative is y4 or d4 or d to the power 4, and so on. Now the nth order derivative can be represented as d to the power ny, or we can denote it as yn of x, and so on. So now, these are how we have learnt how we have to differentiate a function n times. Now from what we are going to do is, when for a given function like y is equals to, let us say y is equals to, if he has given me e to the power ax. Now I am interested in finding out the nth order derivative for this. So that means the nth derivative for e to the power ax. So by doing successive differentiation, means what? If we are going on differentiating continuously one after the other, so then the value of y1, that means derivative of e power ax is a e power ax, and the value of y2 or dy or d square y. So again the double derivative will be a into derivative of e power ax is again a e power ax, so which can be written as a square into e to the power ax. Now again if I differentiate it third time, so that is d cube y, which is y3, is equals to a square into derivative of e power ax is a into e power ax. Again that can be written as a cube into e to the power ax. So if we go on differentiate it till n times, now here for y3 we are getting a3, for y2 we are getting a square, and for y1 we are getting it as a. So if we differentiate n times, so then the value of d to the power ny, so that is yn, will be equals to a to the power n into e to the power ax. So then this is the nth order derivative of e to the power ax. Now, in the same way, we are going to differentiate, or we are going to evaluate some more derivatives of the standard functions. Now, so he is asking us to find the nth derivative of a to the power x. Now, let us say y is equals to a to the power x. Now, if we differentiate this once, so then that will be dy by dx, or let us say dy or y1 is equals to. Now, we all know what is the derivative of a power x, so that is a to the power x log a. Now, again, so if I differentiate it again, so that is d square y or y2 is equals to log a is a constant, then derivative of a to the power x is again a to the power x log a. Or if we rearrange this term, so log a into log a is log a whole square into a to the power x. So this is the value of y2. Now again, if we differentiate with respect to x, so then what do we get? So that is y3 is equals to log a whole square into derivative of a to the power x is again a to the power x log a. Now, so then y3 can be written as log a whole cube into a to the power x. So that means if we go on differentiate it, so the value of yn will be log a to the power how much? For y1 the value is log a, y2 log a square, y3 log a cube. Then for yn it will be log a to the power n into y. So this is the nth derivative of a to the power x. Now again, let us say we'll find the nth derivative of derivative of 1 by ax plus b. Now, let us say y is equals to 1 by ax plus b. Now, if I differentiate it, so that is dy or y1 is equals to, now derivative of 1 by ax or 1 by x is minus 1 by ax plus b whole square into derivative of ax plus b is a. Or we can write dy is equals to minus 1 into a by ax plus b whole square. Now again, if I find d square y, so that means again I am differentiating with respect to x, so that is minus 1 into a into, now the derivative of 1 by x square is minus 2 by ax plus b whole cube into derivative of ax plus b is again a. So then this equals to minus into minus plus 1 into 2 into a square by ax plus b whole cube. Now again, if I differentiate this again, so this is the value of d square y. So the value of dy is minus 1 into a by ax plus b whole square, and in the same way d square y is equals to 1 into 2 into a square by ax plus b whole cube. So in the same way, if we find d cube y, so then that is 1 into 2 into a square into, now the derivative of 1 by x cube, that is minus 3 by ax plus b whole cube to the power 1, so that is to the power 4 into the derivative of ax plus b is a cube. And if we rewrite this term, so that is d cube y will be equals to minus of 1 into 2 into 3 into, sorry, this is a into, this is a cube by ax plus b to the power 4. Or can we write this one as minus 1 cube into 1 into 2 into 3 can be written as 3 factorial into a cube by ax plus b to the power 3 plus 1. So then Again, d square y can be written as 1 into 2, that is minus 1 to the power 2 into 2 factorial into a square by ax plus b whole cube can be written as ax plus b to the power 2 plus 1. Now in the same way, if we write the nth derivative of nth derivative of 1 by ax plus b, so what we are going to get, so that is d to the power ny is equals to, that is minus 1 to the power n into n factorial into a to the power n by ax plus b to the power n plus 1. So this will be the nth order derivative or the nth derivative for 1 by ax plus b.